Okay, we're Bear Incorporated, and we're gonna hunt your problems down until they're fixed. I'm John.
I wonder where that's going.
I'm Steve.
I'm Nick.
And this is our prototype.
It's called the Toy Tugger.
Yeah.
Our design brief is basically an inclined plane with a pulley at the top and a wheel and axle at the bottom. The weight up to the top. And the point of it was so if kids are having trouble putting their toys in the toy box, they could just hook it up, turn the wheel and axle until it just dropped in.
So we did some brainstorming, and each of us had our own brainstorming ideas. This was the first one. Was John's. And he will talk.
Yeah. So my ideas would be to have an incline plane there, and then have some kind of like sprocket system on the back to pull the weight up the incline plate. That was mine.
Then we have Nick's.
Mine was pretty close to that, but it was basically the same, but after we decided to put the wheel and axle at the bottom, because I had the wheel and axle and the pulley up there.
And then with mine was pretty much almost like Nick's, but I had the wheel and axle on the bottom, like down here, like the other group did. I had other sketches, but decided to not use them. And this turned out to be our final design. Well, final idea before we actually started making it.
And then our decision matrix, like I said, Steve's and mine were pretty much the same. So we ended up having the same total score, and John's was a bit lower.
Well, since we had the same thing, we decided to do the same basic concept, but due to our materials, we decided that it would be best to have the wheel and axle down at the bottom, as you can see down there.
Yeah, so this is the final sketch. Just a side view of it. There's the pulley, the wheel and axle, and the ramp. And those are the distances, size of it. So it would fit within our constraints.
Now, here's a little video of the weight going all the way up from the bottom to the top. It's not the fastest, but it does have a great mechanical advantage. Then as it approaches the top, it just falls down and slides into the toy box. Now, this is our wheel and axle, and it's located down towards the beginning of the machine. The wheel itself is 108 millimeters in diameter, and axle is 3.6 millimeters in diameter. The incline plane is 37 millimeters high off the ground, not off the plane, but exactly off the ground. And it is 55 millimeters long. And this is just a fixed pulley down here. Those were our three simple machines that we had in our simple compound machine called the Toy Tugger. And we also had a fishing line for the rope to reduce friction, and we covered the incline plane with duct tape, also again to reduce friction, because without it there would just be holes and the weight would just keep getting stuck and jerk. Moving on to our calculations, Our IMAs of each simple machine were 1-to-1 for the pulley. The wheel and axle, it was our DE was 108, and our DR was 3.16, which equal to 34, approximately 34 IMA for that. Then the incline plane had 55 and 37, which equaled 1.48 about IMA. Our total IMA we calculated by multiplying all the IMAs of the simple machines, and we came out with 50.8 IMA of the entire machine. Then we, to find the AMA, we measured how much newtons the weight itself, and it averaged to about 9.8 or 10ish, but we decided to use 9.8 newtons. And then the way we figure out how much force it took for the weight to move up the plane, we wrapped the string around the wheel, and then tied it to our pressure gauge meter, and then slowly dragged it as the weight went up. And that turned out, it took about 0.6 newtons to turn the wheel and lift the weight up the inclined plane. And total IMA was 16.3. And then the efficiency was just calculated by doing the total mechanical advantage over the ideal mechanical advantage. The actual mechanical advantage over the ideal mechanical advantage times 100, and it turned out that our machine was 32.2% efficient, and we had no gears in our machine. Are there any questions?
I had one about the inclined plane. You said it was 51 millimeters long?
55.
55 millimeters?
Yes.
You're going with that?
55 centimeters.
Okay, all right, that would make sense. So your IMA would still work out, right? Because you said millimeters for both of them, so your ratio would still be okay. But that would be a really small inclined plane, so I just wanted to make sure we...
Did not process that.
It's all right.
It is centimeters.
It's good. I had a feeling you probably meant that. Any other questions?
What's your favorite type of bear?
Our bear.
Okay, good job.